This video is on Chapter 40, Separable Differential Equations, Part 1. So, we start with an equation. So this is our differential equation. We have the derivative of y with respect to x is equal to 6x squared plus 1. And we have an initial condition. This initial condition, y of 1 is equal to 4. So remember, y is a function of x. Sometimes we'll solve for y implicitly in terms of, or explicitly in terms of x, and sometimes we won't. But y is a function of x, and so when x is 1, y is equal to 4. So we start with our equation. dy dx is equal to 6x squared plus 1. This is called a separable differential equation, so now we're going to separate the differentials. So we keep the terms involving y's on one side, the terms involving x's on the other side. So we'll multiply both sides by dx. And so now we have the differential dy is 6x squared plus 1 dx. And now we apply the integral operator to both sides. So we integrate on the left, we integrate on the right. Here we're just integrating 1 dy. And so the antiderivative is y. Here we're integrating a polynomial, 6x squared plus 1. So the antiderivative is 2x cubed plus x plus a constant. Now this is not an arbitrary constant because we're given an initial condition. Remember, the initial condition is y of 1 is equal to 4. That means if we substitute x equal to 1, then y is equal to 4, and we make that substitution in this equation. And we do that right here. So y is equal to 4, x is equal to 1. So now we have substituted 2 times 1 cubed plus 1 plus c is equal to 4. We solve for c. And so our equation is y is 2x cubed plus x plus 1. Part B, we're given the differential equation dy dx is 3 divided by 2y. We have two initial conditions. X is greater than or equal to 2, and y of 2 is equal to 1. This means that when x is equal to 2, y is equal to 1. So again, we start with our equation. We put the y terms, so the 2y and the dy on one side of the equation, one side of the equal sign, and the x terms on the other side. It will not matter exactly what we do with the constants. I left them like this because they'll work out later. They'll work out nicely later. Apply the integral operator to both sides. Then we integrate 2y, and we have y squared. That was a good reason for leaving the 2 here. Antiderivative of 3 is 3x, and again we add a constant. This is not an arbitrary constant because of our initial condition. So the initial condition y of 2 is equal to 1. This means when x is equal to 2, y is equal to 1. So we make our substitution right here. We substitute 2 for x, we substitute 1 for y. So we have our y squared plus, which is 1 squared, plus 3 times x, and x is 2. And so we solve for c, and that gives us our solution. Y squared is equal to 3x minus 5.